As we discussed, three critical aspects while solving a problem: basic concepts, understanding the problem, and the right approach. The point is, we need to work on these ideas one by one. Let's take a few examples to understand why I'm saying concepts, then we're going to switch to understanding the problem, and then we're going to take the right approach. Let's see. When I say concepts, what kind of skill sets required? Let's take an example to understand. I'm writing two expressions, 4 minus 2 square and minus 2 square plus 4. I'll pause for a moment, just try and tell me, are these two expressions different or same? Or there is any similarity in two? If you guys can see, we have 4 minus 2 square and here we have minus 2 square plus 4. Before we proceed further, let's understand what exactly it is. When I say minus 2 square, and I'm getting one more expression similar to this, which is minus 2 whole square. What exactly the difference in two? Here, while solving this, one thing is going to come, which is BODMAS. Why I'm getting into this in this particular picture, if I relate? Because while solving, square is indirectly back of the mind, it's going on, it's going to be a positive expression. When I say it's going to be positive expression, so positive plus positive, so the outcome is going to be positive. That's how we can relate. Sometimes we make assumptions and we relate, we end up solving the problem. But here, if I just structure the issue that says BODMAS, that says brackets, order, division, multiplication, addition, subtraction. If I just straight away use it, what exactly it is? When I'm solving minus 2 whole square, the outcome is going to be minus 2 is multiplied twice, and that is giving you 4. So what exactly I'm going to get here? When I'm saying minus 2 square, if I use BODMAS, and in GRE we're going to focus on PEMDAS. What exactly the difference in two? They're exactly same. The only difference is words. Here we're writing brackets, here we're writing parentheses. So brackets, order, division, multiplication, addition, subtraction, and here we have parentheses, exponents, multiplication, division, addition, subtraction. That's how the difference is, nothing else. Which means if you can see, this is what we have order and this is what we have exponent, which is indirectly the same thing. If I relate here, which means if there's no bracket, we have to first solve the exponent, which means we have to solve this, and here we're going to get minus of 4. This is one aspect, the way we can relate the concept here, which is coming from PEMDAS or you say BODMAS. Apart from that, if I just relate the expression, what exactly we have 4 minus 2 square and minus 2 square plus 4. Two different expressions. Right now, I have no idea these two are identical or not. Let's say I add 4 to both sides. After adding 4 to both the sides, I can see both the expressions are exactly same, identical to each other. If I can see 4 minus 2 square plus 4, 4 minus 2 square plus 4. If I just stick to this, I can see right now the expressions are same, which means even if I'm going to remove 4 from both sides, still expression is going to be same. Let's say which means I have cancelled 4 from both the sides, which means still both the expressions are same, which means here I'm going to get 4 because minus 2 square is minus 4. Here we have 4 and minus 4, which means here I'm getting 0 and here again I'm getting 0, which means it's about concept, the way you relate, the way you understand. It's not that we're going to go on the basis of assumption, like square is going to be non-negative number, which means cannot be negative. On that basis, we answer this is going to be a positive expression. We can't relate that. We stick to our basics, what exactly we have learned so far. Let me just clear the structure. Let's take another example to understand what I'm trying to say when concepts going to play very, very important role. Sometimes while solving the problem, we end up using formulas. When it comes to formulas, there is no end. Let's say, if this side is 3, this side is 4, what exactly the third side is? While looking at the figure, first thing comes in mind that says Pythagorean theorem. To figure out the third side, we can use that. When I use the Pythagorean theorem, which is p square plus p square is equals to h square, where p is 4, 3 square, that says h square. And here I'm getting the value of h is 5, which means I can relate this side is 5. But as I told you, this is a look of your quantitative reasoning section is going to be. And if you're just going to focus on this paragraph, which is clearly saying that geometric figures are not necessarily drawn to scale. This is actually taken from ETS official guide. That is, you should not assume that quantities such as lengths and angle measures are as they appear in the figure, which means you cannot assume on your own. All the geometric objects are in the relative positions shown. When it comes to triangle and we're using Pythagoras theorem, we have to use Pythagoras theorem when this angle is 90. If it is not mentioned, which means we cannot use Pythagoras theorem here. Which means, yes, formulas are there, but the point is to what level and when to use. Each and every information plays very critical role. When it comes to formulas, yes, formulas, what are stated, they always gonna stick to that. They never gonna go beyond that. If I say area of triangle, which is half into base into height, so they're never gonna go to Heron's formula, which we have done somewhere in school back. The point is, yes, each and every concept and information what is stated there gonna play very, very critical role. When it comes to understanding, after concept, the point is the way you read, the way you comprehend things. Let's take an example to understand that. Because concept, yes, but the way you read, the way you relate, which is also important. Let's say there are 4 terms, A, B, C, and D. And all these 4 terms are equally spaced on number line, which means the distance here is going to be same as the distance here is going to be same as this one. D is given as 2 raised to the power 12 and C is 2 raised to the power 11. What is going to be the value of B? Which means here I'm looking for the value B. Sometimes we end up using different concepts and we unnecessarily create issue because we never understand what exactly the statement is saying. When I say A, B, C, D, they are equally spaced, and indirectly without understanding what exactly the question is saying, I end up answering this as 2 raised to the power 10 because I can see a pattern. Because we always be looking for, let's say, some shortcuts, some tricks are there. But the point is, when you just relate what exactly the expression is saying, it's going to be very easy to understand. Or I'm simply trying to say, try and keep it simple as possible. If you relate here, what I'm saying that A, B, C, D, they are equally spaced, which means the difference between D and C is going to be same as the distance between C and B is going to be same as the distance between B and A. That's how I'm trying to relate because that's what exactly given to you. A, B, C, D are equally spaced. I'm looking for the value of B. C and D are already given to you. If I use this expression because C minus B is equals to D minus C, which means I can relate here the value of B is going to be twice of C minus D. That's what I'm getting here. Instead of assuming things or relating different ideas, different concepts, some shortcuts here, if we just end up getting the same idea, what exactly stated there. Here I've simplified and I'm getting B is what? Twice of C minus D. If I just plug in values, what I'm getting here? C. If you relate here, I'm getting 0, which means this is clearly incorrect. Which means sometimes we end up wasting our time getting into complications like can we see a pattern there, can we understand some shortcuts are there, or we can relate some formulas to figure out the answer. Or what else we can do, what best we can do here, we can keep question as simple as possible and make sure what is given to you is sufficient to answer this question.